Welcome to this lesson on angle relationships. Today we're going to talk about how to identify different types of angles. So we have complementary angles, supplementary, vertical, adjacent, alternate interior, alternate exterior, same side interior, and linear pairs. Right, so first we're going to define each of these. So complementary angles are angles whose sums are 90 degrees. Now, typically we see these angles as put together, but they do not have to be. So in your example, you should have two examples that you write down. So here's an example of two angles that are complementary, but they are not connected. They're still considered complementary angles because 56 plus 34 gives you 90 degrees. So it makes a 90-degree angle. And here I'm going to use my straight line tool to draw my angle. So I know that this is 90 degrees, but then I'm going to split it. Right, so now these are complementary angles. And then we can put in here that this is 30 degrees, and then this would be 60 degrees. Now, sometimes they might not show you the degree measures, but if you see this square here, even though this line is through it, these would still be complementary because this big angle here is still a right angle. Remember now, there are three angles here. There's the 30-degree angle, the 60-degree angle, and the 90-degree angle. Supplementary angles are two angles whose sums are 180 degrees, so they make a straight line. Remember, a straight angle is a 180-degree angle. Again, they do not have to be connected, so here you have 55 and 125. Added together, they give you 180. Or you can have, again, a straight angle, so I'm going to use my straight tool here. And then I'm going to intersect it. Right, and now I have, and let's go with 70 and 110. Okay, so now these two angles would be supplementary. Vertical angles. Vertical angles are angles that are opposite of one another when two lines intersect. So here I have two lines that are intersecting. So this angle here, angle B and angle A, are vertical angles. So kind of imagine that you're folding the angle in half. Let me get my dotted line here to show you kind of what I'm talking about. Harder than it looks. Here we go. Right, so let's say that we fold this angle in half right about here. So when you fold it in half, these two angles would match up. Okay, they have that symmetrical, they would fold together. Those are vertical angles. Right, so they're angles that share the same vertex. They start from the same spot, but they don't share the same ray. So notice this side of the angle here is not part of this angle over here. This line is, but in this case, this angle has its own ray and this angle has its own ray, and they're two separate entities. Right. Adjacent angles are two angles that have a common side and vertex. So in this case, if they have a common side and vertex, they're next to each other. So even these would be considered adjacent angles in terms of your complementary and supplementary that are put together. Otherwise, here you have angle ABD, ABC, and CBD. And the two angles that are adjacent are ABC and CBD. So you have these two here that are touching that are adjacent. And then here, if you want to look at the vertical angles, right here, so here's angle A. This angle right here would be adjacent to angle A because they share this side and they have that vertex in common. Alternate exterior angles. So this is where you have to have a transversal, and that's a line that intersects the two other lines in really simple terms. And alternate exterior angles, so they're going to be the ones on the outside. So think of it's the ones that aren't crunched between the two lines. They're on the outside, so they're either on the top and the bottom. So a pair of angles on opposite sides of the transversal, so here's my transversal, so here's one on one side, and then here's the one on the other side. but they're on the outside of the two lines. So again, these are on the inside. So if you look here, here's the line. It's like they're the middle of the sandwich. They're the meat of the sandwich. And A, B, G, and H got left out. Those would be your exterior angles, and A and H would be considered alternate exterior angles. You could also say that G and B are exterior angles, alternate exterior angles. So then under the same conditions, alternate interior angles, these are going to be the ones that are sandwiched together and on opposite sides of the transversal. So again, we have a pair of angles on opposite sides of the transversal, but inside of the two lines. Okay, same side interior angles. They're going to be the ones that are on the inside and the same side. Pretty sure the name really helps you out there. Linear pair. So a linear pair is a pair of adjacent and supplementary angles. So when you have supplementary angles that are connected, so they're all part of really one line that just got intersected, those are considered a linear pair. So if we go back to our supplementary angles, here you have supplementary angles, but they're not connected, they're not adjacent, they're completely separate from one another. Here you have supplementary angles, but they are adjacent, they both share this line or this side in common. Alright, so complementary angles. Again, complementary angles are going to be those angles that make 90 degrees, whether they are together or not. So here, if you can look past all the intersecting lines, you know that you have those lines in the background that are perpendicular that make the 90 degrees. So then these angles here would be considered complementary. And then you also know that, so those would be complementary. We could say that these two are also complementary with each other. Okay, so complementary angles, if you know one, you can find the other. So with complementary and supplementary angles, these are the only ones we're going to talk about measure today. So if you know, if it says that the angles are complementary and it says what's the complement of 62 degrees? Well, I needed to take my 90 degrees, so that would make the right angle, subtract the 62 degrees that I already have, excuse me, and I would get 28 degrees. So it's called the complement. The complement of 62 is 28 degrees. So let's say that they told us that this was 68, then by doing this math, we could find that this was, 62. Then we could do the math and find that this was 28. Supplementary angles and linear pairs. Again, if you know that it's all a part of one, then they're considered a linear pair. So here you have two sets of supplementary angles. Again, you have more than two. So you have this one and this one, because together, so if you add this plus this, that gives you 180 degrees. You also have here and here. So even though this line is slanted, it's still a straight line in terms of angles. And we're not talking about straight as in perfectly straight, we're talking about straight equaling 180 degrees. You could actually turn this figure, and I'm going to actually do that. So I could actually turn this figure to a point where it makes that line straight. Okay, so it is a straight line, it's just written, or drawn, I should say, on a slant right now. All right, so these two, again, if you take a look at it, here's this angle plus this angle gives you 180 degrees. All right, then you have here and here. So this big angle here added to this, and actually I should do it like this, so that way it connects well with the other one. So here's this angle here, and here gives you 180 degrees. And then last but not least, you have this angle here and this angle here. Oh, sorry, I already did that one. I meant this angle here and this angle here that give you 180 degrees as well. Right? So you have all these different supplementary angles. My suggestion, take this and draw it several different times. So draw it 4 different times. So there's one. Okay, and then what you're going to do is each time take a little bit away from what you did. So I would draw the different options that you have. So here, let's take away the purple and the red and the blue. Okay, and just show the pink supplementary angles. And then draw another set and just show the purple supplementary angles. Okay, and then do another one where you show just the red supplementary angles. Ooh, that became a little bit more complicated there. Try that again. Move this out of the way here. And I can put this back real easily. Okay, and then the last one, leaving just the blue supplementary angles. That might be a better way to show it. I know there's a lot of lines going on here, so make sure you're drawing it nice and small and drawing it so it makes sense to you. Right? They're your notes, so make sure that you can understand them. All right, so here's all of our different options that we have. And the red one. Vertical and adjacent angles. So here we're just identifying these. That's what we're going to be spending a good chunk of time doing, because if you can't identify which angles are vertical, you're not going to be able to use the information about their measures to help you out at all. So here, let's identify vertical angles. So I'm going to identify a pair first, and then I'm going to have you pause and try to identify some others. So I'm going to start with angle A. Well, vertical angle to angle A is, okay, so here's its vertex, and it has to be opposite. So if it's looking straight across, then angle D would be vertical to angle A. Okay, again, I want you to go ahead and pause if you feel like you're ready. Otherwise, I'll do a couple more. And then these over here, you will definitely be doing on your own and coming back and checking. So here you have angle B and angle C that are vertical angles. All right, so I want you to go ahead and pause and try to find the 2 sets of vertical angles here. And now that you're back, vertical angles. Okay, so don't forget to put that these are vertical. Oh my goodness, this is not a good writing day for me. Right, and then also, so I'm going to start with angle E, and vertical to angle E is angle H. And then angle G and angle F. Adjacent angles. So again, let's start with angle A. Angle A can only have one vertical angle, but it can have 2 adjacent angles because it has 2 sides that it shares. So angle A shares a side with angle B, so angle A and angle B are adjacent. Angle A and angle C, so it shares this side right here with angle C, those are also adjacent. Now, you can't say that all 3 are adjacent to each other because B and C are vertical. It means that they don't touch. The only thing they share is that vertex. So adjacent angles can only be adjacent with each other, not with a third. Okay. And then we also have, let's keep going around the clock. So we have B and A, so now we know that angle B also shares a side with angle D. And then we have angle D and B, and then D also shares a side with C. And then we have C, which shares a side with D, and C, which shares a side with A, but we already have those written down. So now I'd like you to take a moment and pause and try these on your own, and then come back and check your work. So we have angle E and angle F and angle H and angle G and angle E. This time I just went around in a circle and figured out which ones were adjacent. You can do that as well, or you can start and do E and do both for E and then just do the one for the each that are left. Right. Same picture, but now we're going to do alternate interior and exterior angles. So I'm going to abbreviate, so alternate exterior, and alternate interior. All right, so even though it's not as nicely drawn with this one, B, E, D, and G. So let's actually first identify our interior angles. Again, our interior angles are the ones that are going to be inside of these two lines. So the ones that fit inside of here. Okay, that's the interior of this. So the angles that are inside, where all of that green is, are going to be angle B, angle D, angle G, and angle E. That leaves for exterior, that leaves the ones on the outside. So angle A, angle C, angle F, and angle H. So for our alternate interior, so you have different sides of the transversal as well. So you have this side that has the pink, and you have this side that has the blue. So you have B, which is on the inside. So basically what you're looking for is one that is green. So both have to be green. So both inside, which is the green area in this case, but opposite sides. So one blue, one pink. Right, so let's start with B. B is inside the green and it's on the blue side. So we need one that's on P. Okay, so it's on the opposite side, but it's got to be over here. So it's got to be on the other line. So angle B and angle G. Okay, they can't be a part of the same set of four, essentially, or they can't be a part of the same set created by the intersecting lines here. And then we have angle D, which is in the pink, and the alternate interior for that is angle E. So again, and I'm actually going to do those in different colors. So let's do this one in yellow, and then this one was in purple, and yellow, angle D. Ooh, yeah, you can see that really well. And then your alternate exterior angles. So now you're looking at the ones that are outside. So both outside. And then again on opposite sides. So again, the blue and the pink. So the blue and the pink actually extend. So the blue extends here, and the pink extends here. Well, and here, I should say. All right, but the green stays on the inside. So the white space, so this is white, would be the exterior. So white, and then one pink, one blue. All right, so here I'm going to use green, and I'm going to start with A. So it has to be on the other side and on the outside. So on the other side and on the outside would be H. So angle A and angle H. And then let's go ahead and use pink. Here's F and C. Okay. So again, this takes a little bit of time, but if you sit down and break it down, you will get used to it, and we're going to spend a lot of time practicing it, because again, if you can't identify them, then you can't use their relationships to help you find angle measures. Same side interior. So again, we're looking at that green area on the inside. Green area. Okay, that interior that's created by these two lines that we have here. And now they have to be on the same side. So we have B and E. So angle B and angle E. And we have D and G. Okay, again, that one is pretty straightforward, fairly simple. All right, so here you have two lines split by a transversal, and it asks you to name different angles. So an angle that's vertical with angle G, linear pair with angle G, so on and so forth. So you can find each of these. There is a specific answer for each one of them. The one that talks about adjacent, though, this one here, so name an angle that is adjacent to angle D. There are two choices for you. You can either give me both or give me one. It is completely up to you. Right? As always, if you have any questions, be sure to write them down or email me so we can go over them in class.